Hello friends, welcome to Susan and John MacTube. In this video, we're going to learn about harmonic functions and how to create the harmonic conjugate. And this is extra important, especially for the engineering students. Okay, so question number 1, define a harmonic function. Very simple. Let u be a scalar valued function in two or more variables. Anyway, here we are given a two variable function. Can you see? A variable which depends on x and y. So if you want to prove that a function is harmonic, you have to prove that that function can balance the Laplace equation. Now, Laplace equation is nothing but the sum of the second order partial derivatives will be equal to 0. Here we have two variables, so I got uxx. I hope you still remember. Ux means differentiating the given function by treating x as the only variable, and uxx means the double derivative. So let's take this as an example. U equal to y cube minus 3x squared y. I can write casually as u, but if you want to be more mathematical, you can call it like a function in x and y. Anyway, this will be more comfortable. Now, ux means you have to differentiate by treating x as the only variable. And that gives me the answer. Come on, what's the derivative of y cube? Not 3y square, it will be 0. Because x is the only variable, so y is going to be a constant. Minus 3 is a constant, y is a constant, and this is a product multiplied by 2x, and that gives minus 6xy. I hope you are not confused. How do you differentiate constant multiplied by x squared? You will keep the constant and differentiate the function. Same thing, look, 3 is a constant, y is a constant, so I kept it there just like this 5 and multiplied by the derivative 2x. Similarly, what will be uy? That will be 3y squared minus 3x squared into 1, because I am treating y as a variable. Now the last step, uxx, I am not explaining it. You already know what to do. You have to differentiate this stuff again with respect to x. So that gives me minus 6y multiplied by 1. Uyy, so not that surprisingly 6y. Add them up, it is equal to 0, because this is a show that question. So if someone asks you what is harmonic, all you have to tell them is the sum of the second order partial derivative should vanish. Or you can simply say the function must balance the Laplace equation. This is the Laplace equation. And if they ask you prove to be harmonic, all you have to do is prove that the sum of the second order derivative equal to 0. But now comes the most important part. Now look at this. There are many applications related to flow, gravitational field, etc. in which you have to find an orthogonal system. And while finding orthogonal system, all you are doing is you are creating a complex valued function. So you are given a particular function and you are going to create a complex valued function by constructing this v. So what I am going to do is I am going to assume let this be the required complex valued function. Now I think you had been watching all the videos in complex analysis in order. When we derived the CR equations, we derived this. The derivative is equal to ux plus ivx. And then I taught you Mill-Thomson method. Okay, So I'm going to take advantage of this process. So I'm going to write this as ux minus iuy. Come on, who can tell me why I am able to write like this? Can you see? I am trying to find this v, but all I know is u, and I know this function is an analytic function. That is how I am assuming. And if it is an analytic function, ux equal to vy and uy equal to minus vx. Obviously, this means vx will become minus uy, and that's it. And we already know the values. So I just plugged in the values. Now apply Mill-Thomson method. Mill-Thomson method means replace every x with z and y with 0 in the derivative. So that becomes 0 minus I into 0 minus 3z square. That means f dash of z equal to 3iz square. Wait a minute. Let me explain it very clearly. We defined a harmonic function. We proved that the given scalar valued function, not complex, the given scalar valued function is harmonic. Now what we are trying to do is we are creating another function, namely v, in such a way that u plus iv will be analytic. That is exactly what the question asks me to do. Okay, so I need the function. If you know the derivative, how will you get the function? Very simple. I'll write integrating with respect to x on both sides. What is integration of derivative? It will end up like the function, and this side I have to integrate, and that's not a big deal. That will give us 3i is a constant, and set to the power 3 divided by 3 plus of course the constant. We got the function I into z cube. So that's it. But wait a minute. In your application questions and sometimes in the math exams, your teachers might ask you, what is the harmonic conjugate? If you ever see the word find the harmonic conjugate, then that means they want the value of v. Look at this. Right now we have the function. By the way, don't forget plus c because we did integration. Now if you want capital V or small v, whatever you call it, the harmonic conjugate, we will do separation. That is what we learned long back. The output will be called u plus iv and input will be called x plus iy, and that means u plus iv equal to I into x cube plus 3x square iy plus 3x I square y square plus I cube y cube plus c. That means u plus iv equal to, I just applied a plus b the whole cube, and then let's take this I inside. I hope you still remember root under minus 1 is I squared is minus 1, I cube is, you fill it, I power 4 is 1. So I'm going to take it inside. So I get I x cube, I squared is minus 1, so I'll make it minus. Then I cube, come on, tell me what is I cube? Yeah, minus I 3xy square, and this will become I power 4, so that will be plus y cube plus c. Now look at this. When you compare both sides, you'll be able to see that I can equate the part that comes along with I, and that gives me v equal to x cube minus 3xy square, and that is the harmonic conjugate. Now let's quickly do one question and make the concept like really good. Okay, define harmonic conjugate. Come on, pause the video, define it. Write it. My recommendation is write it so that you'll feel like so comfortable in your exam. Now, determine an analytic function in such a way that this function is analytic and u is equal to this. Same thing. So define harmonic and let's try to prove harmonic. So ux equal to e power x sin y, uy equal to e power x cos y, uxx means that will be e power x sin y, uyy will be e power x into minus sin y, and can you see the sum of them will be 0. So easy. Now comes the second part. Find the harmonic conjugate or find the function. So I'm going to do it like this. Let V be the harmonic conjugate. Don't forget that word, harmonic conjugate. If U is given, V is the harmonic conjugate. If V is given, U is the harmonic conjugate. So let V be the harmonic conjugate in such a way that f of z equal to u plus iv is analytic. Therefore, the derivative is equal to ux plus ivx. From where did we get it? CR equation. Now, I'm going to convert everything into u or v. U is given, so I have to convert it into u. So, ux minus I uy. Come on, explain it to yourself. So, f dash z equal to, I got the values here. E power x sin y minus I times e power x cos y. Now Mill-Thomson method. What is Mill-Thomson method? F dash of z equal to e power z. Sin 0 will be 0 minus I e power z. Cos 0 will be 1. So we got the function minus I e power z. No, not the function, the derivative. So what should I do next? Integrate f of z equal to minus I integral e power z dz. So I have to integrate on both sides. The complex constant goes outside. So I'm going to get u plus iv equal to minus I into integrating plus c. So u plus iv is equal to minus I into e power x plus iy plus c. You know, I'm trying to extract. We already got the function because the function is nothing but minus I e power z plus c. So u plus iv equal to minus I e power x into e power iy plus c. So u plus iv equal to, come on. If you don't know e power I theta, I will recommend you to watch the first video in complex numbers. What is e power I theta? Yeah, so that will be minus I cos y plus I sin y plus c. By the way, in the previous problem, if they ask you to find the value of v, you have to put plus c. If you don't put that plus c, our answer is mathematically incorrect. Okay, so here we go. Now I want v. V means the part that stays with I. So v equal to minus cos y plus c. That's it. So I'll be back with more videos like this. Do support us and subscribe to our channel.